Good morning, guys. I hope you're well. Today we are focusing on factorising monic quadratics. Now, if you want to go ahead and have a crack at the questions, I'm going to put the questions on the screen now. You can pause that if you would like and then fast forward through my gibberish and then go through the answers. Otherwise, if you need to learn how to do or look at factorising monic quadratics, then most welcome to follow on. Okay, so first of all, what is a monic quadratic expression? So you might remember things like x squared plus 6x, right? We've done those things for many years in year 7, 8, and 9, where we just factorize. Now that's technically speaking a quadratic equation. What we're going to be looking at is things like x squared plus 6x plus, let's say, 5. Now, these are monic quadratics because the quadratic component, the x squared, only has a 1 in front of it. Therefore, they become monic quadratic questions. Now, the first one would be nice and simple because there are only two terms. There is, of course, a common factor. That common factor is x. I factorize that out, I get x plus 6. The problem with the second one, though, unfortunately, is there's no real common factor apart from 1. So we have to look for an alternate method to solve this, or to factorize, should I say. Now, when we're factorizing, there are probably going to be 3 main methods that you may look at. Now, depending on your teacher at school, you may do a slightly different method. And because this is technically year 10 work, you should have done this in year 9. So whichever method you are familiar with, that's probably a good one to kind of continue. Now, my main method is the product and sum method. A lot of teachers will call this the PSF method. There's also the cross method. And there's also one that I call the division method. Now, monic quadratics are much easier to factorize than non-monics. However, I always start by factorizing it the non-monic way, because then you can apply that to a non-monic question later on. But I'll certainly show you the easy ways to do things. So the product and sum method, or the PSF method, is where we first of all want to get some values for the product and sum. And what that means is we're looking for the numbers that are timesing together. So in this case, the P comes from the first number times the last number. 1 times 5 is 5. Don't just think it's the last number. It happens to be the last number for monics, but when you have a non-monic like a 2x squared, then that product would be 10. So we've got to be very careful there. So 1 times 5 is 5. The sum is the number in front of the x, or the middle value there, but it has to be in front of the x value because they could be rearranged, of course. So that's a 6. Now, what we're looking at are for the factors, right? What are 2 factors? What are 2 numbers that, remember, product means times, multiply together to give 5, but add together to give 6? Well, the only 2 numbers that multiply together to give 5, because it's a prime number, is 5 and 1. 5 times 1 is 5. 5 plus 1 makes 6. So there are 2 numbers. Now, what we would generally look at in that instance, there is a shortcut method which you could do straight away. I'm not going to do that just yet. What we generally are doing this for is because what we want to look at, we want to try and factorize this like we had that first question, but we can't factorize anything there. So what we're actually going to be looking at is splitting that 6x up into these 2 factors. So 5x and 1x. So what we actually have is x squared plus 5x plus 1x plus 5. Now, the reason we do that, we now have 4 terms. We can split them into 2 halves, and we can now get some common factors out. So, for example, x squared plus 5x, well, x would be common. So I'm going to have x plus 5. And the second letter brackets, well, nothing really else goes into it apart from 1. So I'm going to put a 1 at the front, and that x plus 5. Now, is there anything there that you recognize? Well, I'm hoping you think and look at and go, hold on, the 2 brackets are exactly the same. Now, we saw this in a previous lesson. Okay, for example, when we had that x squared plus 6x, we noticed that an x went into both, so we took the x out the front. And whatever was left over went into that second brackets. Same thing happens here, except instead of the x being common, we have an x plus 5 being common. So the x plus 5 whacks out the front of the brackets, and then whatever is left over goes into that second set of brackets, which is the x and the plus 1. And that becomes my answer. Now, again, this should be revision. We should have done this in year 9, so it shouldn't be totally new. Now, if you look back at those factors, what do you notice? Well, hopefully you remember when you are looking at monic quadratics, when you find the actual factors, you can in fact go straight to your answer because they will always be the same. So you can see that the positive 5, x plus 5, or the positive 1, x plus 1 works every single time. For monics, not for a non-monic. Non-monic, we must do this longer method every single time. So that's my first method we're looking at. And for most people, that's what we are looking at to solve. The second method is one that I don't like as much, but certainly I know a lot of students will use it. And that's what we call the cross method. Basically, we put a cross there. We put the factors that make the x squared. So in this case, it's x times x. Okay, and then similarly to the product and sum method, we're simply looking for two numbers that multiply together to give 6x, multiply together 5, and that would obviously be 5 and 1. And when we multiply through the diagonal, x times 5, we get 5x, and then x times 1, we get 1x. We hopefully want to add those together to make 6x, which we do. So therefore, we look at it as x plus 5 and x plus 1. Now again, I don't encourage the cross method unless you've learnt that in class or you've been taught that in class. Again, I like the PSF method, that's just me. The division method, again, probably not one that I use a whole lot. The division method, I mean, for this one, it's not really going to make much of a difference. It looks almost like the first one. Okay, the division method still does the PSF. You still get your 5 and 6, which means you're doing 5 times 1 is 5, 5 plus 1 is 6, and then you go straight into brackets. The only issue is later on when you have a non-monic and you have a number in front of the x in both of them, you then divide by that number. Okay, now in this case we got a 1 and a 1, so I'm dividing it by 1. Doesn't make much of a difference. So for me, realistically, the division and the product sum will be the same for monics. So you won't see much of a difference until we do the non-monics, of course. But the cross method is certainly a little bit different. And it's up to you on what you look at. Now, these are some questions that we had here. So I'm going to go through each of these ones fairly quickly. Remember, you can pause this and come back to it if you need to be. Now, the first one, I've actually split the terms straight away. Okay, so this is just a common factor question. I'm going to take an x out. I get x minus 1. I'm going to take a 4 out. I get x minus 1. Now remember, if you do it correctly, and this is a proper factorization for quadratics, you know that those brackets should be identical, and they certainly are. Okay, and then all I'm going to put is, I'm going to factorize the brackets out, and I'm left with the x plus 4. Good to go. All right, the next one. Now this is where, again, we're coming into our product and sum for me. I'm going to do PSF, I'm not going to do cross method. If you know cross method, go for it. Okay, but I'm doing PSF. Okay, so my product is 1 times the positive 2, that makes 2. And the sum comes from the middle number always, or the number in front of the x. That's the first step. The second step is to look for two numbers that multiply together to give 2. Well, that's an easy one for this question because it's a prime number. It's only 2 and 1. And add together to give 3. In this case, it's just 2 and 1 because 2 plus 1 makes 3. Now, I'm going to automatically go straight into my answer, x plus 2 and x plus 1, and my job is done. You could split the term, okay, and put it into x squared plus 2x plus 1x plus 2, where I've split the 3 into the 2 and the 1, and then factorize the x plus 2 like that, for example. Take the 1 out and see my brackets are the same. But of course, you can see when I take the x plus 2 at the front, the x plus 1 in the other brackets, it's exactly the same. There's no real point doing the long way if it's a monic. Of course, if it's a non-monic, you have to, okay? All right, remember you can pause this if I'm going too fast for you. All right, the next one, product and sum. So my P is my 1 times the negative 5. Well, that makes a negative 5 my P. And the sum, of course, is the positive 4. Now, don't worry so much about the negatives. A lot of people get hung up about the negatives. Just look for your two numbers that times together to give 5. Ignore the negative. So that can only be 5 times 1 is 5. Now, of course, when I'm doing 5 times 1 is 5, Okay, we know that one of them has to be a negative now. But I'm going to look at the second one. How can 5 and 1 make 4 when you're adding them? There is only one way. 5 subtract 1. That makes 4, and all of a sudden, the negative now works with the product because that makes negative 5. So I can now go straight to my answer, x plus 5 and x subtract 1. Job done. Okay, next question. We've got a couple of negatives coming through here, so we get to practice those negative questions. Okay, so the next one, my product and sum. 1 times 7 is 7, and I have a negative 6. So my two numbers, again, I've got another prime number. I love these questions when you have prime numbers, makes it really easy. I have 7 and 1, okay? Now, how can 7 and 1 somehow make negative 6 when you're adding them? Well, there is only one way. That's a negative 7 plus 1, and now I look at that and go, well, hold on. No, that doesn't work, does it? Okay, so 7 one's not going to work. This question actually doesn't work. So this one is not factorizable. Now, in order to make this factorizable, I should have put it as a negative 7, okay? And let's see why. Because minus 7 plus 1 makes minus 6, that works out. But minus 7 plus 1, so times 1 makes a negative 7. So this is not factorizable. Sorry, shouldn't have put that one in there. Okay, now let's say I change the question though, and I make it x squared minus 6x minus 7. Now this one will work because I want to do my product and my sum. I have my 7 and my negative 7 and my negative 6. Now I'm going to do my negative 7 plus 1. Okay, now that works. Now that becomes x minus 7 and x plus 1. Okay, job done. So you've got to be careful there. As I said, when you're looking at the textbook questions and things that you're doing for class time, they're all going to be correct and they will work, all right? Not like my ones. Okay, second last one. I love this example because these combinations are really tough, okay, for the first time. Product and sum. My product is 6 and my sum is negative 5. Now, the reason why I feel this is tough is because when you have the 6 and the negative 5 combo, there are a couple like these, you have more than one combination that might look like it's going to work. So for example, what are two numbers that multiply together to give 6? Well, 6 and 1 work, right? But also 3 and 2 work. Now, can 6 and 1 make negative 5? Probably. Can 3 and 2 make negative 5? Probably. Okay, they both work. However, only one will work perfectly for both the product and the sum. Let's have a look at that. So if I look at the first combination, 6 and 1, how can that make negative 5? Well, the only way that can happen is if I have a minus 6 and I add 1. Now, if I multiply these two terms together, what do I get? Well, I get a product of minus 6. Problem is, I need a product of positive 6. Therefore, that combination does not actually work. If I look at the second combination, how can 3 and 2 make negative 5 when I plus them? Well, the only way that can happen is minus 3, minus 2. That now adds to give minus 5. What happens when I multiply minus 3 and minus 2 together? We make a positive 6, and look, that's what we wanted. So the reason I think that's one of the harder combinations is simply because the two combinations kind of both look like they might work, but only one actually does. But now I've got my combinations. I've got the minus 3 and the minus 2. I'm going to put it straight into my brackets, x minus 3, x minus 2, and that works perfectly. But remember, we can only do the quick method if we have a monic, if we have a 1x squared. 2x squared like next lesson? No, we have to split the terms and factorize a long way. Now, the last one I'm going to do here is a bit more challenging because this actually looks like a non-Harmonic quadratic, and you could solve it that way. The issue is there's actually a much easier way of doing it than actually solving it as a non-Monic. Now, can you see what you could possibly do to start off with? Whenever you are factorizing, the very first thing you should always look for is there a common factor? In this case, there is. I can take a 3 out of this question out of all of those terms as such. Now, notice what you've got inside the brackets now. You've got a monic quadratic. So I can now actually do my product and sum off that monic quadratic term. So my product is 1 times 3, which is 3. My sum is 4. Okay, so what are my two numbers? Well, it's a prime number. 3 times 1 makes 3. 3 plus 1 makes 4. Well, that's good, right? And because it's a monic quadratic, I can now go straight through and say x plus 3, and I can say my x plus 1. The only difference, of course, is I have that 3 at the front, and that is a perfectly solved, well, in this case, it is a non-monic quadratic, but I've solved it in a monic kind of method. Gents, I hope this kind of made sense. Again, this should be revision, so this should be new stuff to you. If it is, well, I can put some more videos up there for the basic part of it, but I'm hoping that you do remember this stuff. Remember, when you have a monic quadratic, you can do the quick method straight away, and we encourage you to do that. We don't want you to do the long method every single time, but we often still need to do it for when we have those harder non-monic questions. Okay, gents, I hope that made a bit of sense. I hope you're doing well. If you're having your holidays now, I hope you're enjoying them. Otherwise, I'll see you very shortly. Have a wonderful day.